on the edge end of a light inextensible string 2 meters long is projected horizontally from a point C. Calculate the least speed of projection needed to ensure that the particle reaches point D, which is vertically above C. Now, the deal is that it's not an R value. Can everybody understand that? It's like it's attached by a string. You get what I'm saying? Yes. Yeah. And it's a T value. It's a tension going back towards the center of the circle. It's not an R value. A couple of people did R values for some reason, and I don't understand why. Now, at the very top of your motion, what can we say at the very top? Imagine the particles at the very top. What's aiming downwards? So imagine I have a red particle at the top. Would you agree that the tension is acting towards the center of the circle, which would be T? What else acts downwards? The actual weight of the particle, which is mg. So at this point in time, it'd be T plus mg acting downwards, and it has to equal mv squared over r. Do you understand the centripetal acceleration always aims back towards center? This is a vertical motion question. What's the other part of this? Conservation of energy, which is Ke1 plus Pe1 equals Ke2 plus, anybody? Pe2. Ke1, Pe1, Pe2. All right. Now, what we're going to have is the following. I'm going to send it off with a projection value of U. Is that okay? U. And what we're going to get? A half mu squared. I'm going to call this the lowest point is a H value of 0. So therefore, it has a potential energy of 0. Ke2, lads, when it reaches the top, believe it or not, it still has velocity. It just doesn't have enough velocity to keep the tension tense. Do you get what I'm saying? It doesn't stop there. It's moving, but it sort of falls inwards. So I was to grab a cable and swing it upwards. You can see this cable's still moving. But it's still moving, but just hasn't got enough velocity to continue the tension. Okay. Yeah. A half mv squared, yeah. And what's Pe2? Potential energy. M G. How high in the air are we at this point? 4 meters. Yeah, it has to be 4 meters. So what I'm going to get here is a half mv. I'm going to multiply both sides by 2. Is that okay? So I'm going to get mv squared is, oh sorry, mu squared. Is that right? Mu squared is mv squared plus 8 mg. Then I'm going to maneuver mv squared. Mv squared stays to the right, and it's mu squared minus 8mg. Is that okay? Now what are we going to do? What can I do here, guys? What's the R value? It goes about a radius of 2, yeah? At the very top, the tension will turn to 0. Because when the tension turns to 0, it barely makes it. It turns 0 at that point. Have we got it? Now what am I left with now? mg, I'll cross multiply up to 2, is that okay? So it's 2mg, and that gets rid of that 2 on the bottom. And what can I sub this out with then? mu squared minus 8mg, and then I'm going to get mu squared equals, what's it, 10g. I'll get rid of the m as well, just cancel out the m's while we're at it. And we're going to get u squared equals 10g, and then 10g is 98, so square root of 98, 7 root 2. Did anyone get 7 root 2? meters per second. You got that? Now, we all good? Okay. Now we're going to go back upwards and it goes, if the speed of projection is 7 meters per second, so it's stating the U value is 7, find the angle that the string makes with the vertical when it goes slack. We're going to have to set up a general system again, okay? And this is where you have to start drawing triangles and stuff. So here we go. Okay. I'm going to need this part again. I know I'm going to need all this again, okay? So just rubbing out all this stuff, and then I'm going back up again, and I'm going, okay, here's what's going on here. I start off with a speed of 7, okay? And I make it up. I don't know how far I make it up, but it says with the vertical. So for argument's sake, I'm going to put it up here. Is that okay? I'm going to put up this high. And what I'm going to say is that this is when it has a V value before the string goes slack. So the V, it's still moving, but the T value will eventually go 0. Is that okay? T value will go 0. Now, what I'm thinking is the following. The first thing is I'm going to do a forced triangle. So there's two moves, isn't there? There's the centripetal acceleration, the mv squared over r. I'm going to set that one up. So here's what we're going to do. I'm going to call this, for argument's sake, I'm going to call this angle x. Is that okay? Gravity acts directly down, agreed? So this blue triangle is now my gravity triangle. That's mg. And again, I'm going to resolve that mg parallel and perpendicular. That makes this one angle x, doesn't it? For what reason? Alternate angles. And I'll also make this one here is angle x as well, for the same reason, alternate angles. Now, what do we think about this line here then? mg, what? mg cos x? That be alright with you guys? mg cos x? Okay, it's mg cos x. Now, here's what I'm looking at. The tension goes towards the center of the circle. The tension is riding along the rope towards the center of the circle as shown. Okay? What other thing is going towards the center of the circle? The mg cos x. Okay? And what does that equal? mv squared over r, but what do we know r is? 2. So technically speaking, it's 2t plus 2mg cos x equals mv squared. Next thing we're going to do, I'm going to get rid of this diagram here because I don't really need it anymore. And what I'm going to do next is going to concentrate on the conservation of energy formula. Once again, angle x. Are we happy that's angle x? Can anybody tell me what would this blue length be? If this is 2, what's that blue length? 2 cos x. What's this green length? 2. What's the combined height then? 2 plus 2 cos x. Agreed? So here we go. We start off on level ground and it's a half m times 7 squared. Happy at 7 squared? Cool? Okay. Plus mgh, which is 0. A half mv squared. The goal of the question. Actually, the goal of the question is to find the angle. Okay. So the goal of the question is to find out x. Yeah. And then what about P2? It's mg times what? 2 plus 2 cos x. Sorry, that looks terrible. 2 plus 2 cos x. Now, let's go for the green part. 49 over 2 m equals a half mv squared plus 2mg plus 2mg cos x. Now guys, I'm going to multiply both sides by 2. Is that okay? And I'm going to take them over at the same time. So what's my next line look like? Anybody tell me? 49m, yeah. Minus 4 mg minus 4 mg cos x. If you will, multiply both sides by 2 and then transfer over. Is that okay? Now, what can I say now? No need. Yeah. What can I say about t? T is going to equal 0 at the point it comes slack. So see that t? Gone. What's left then? mv squared is 2mg cos x. I'm going to bring that 4mg out your side. Alright, some of you might need to help me out with this now in a sec. Would you all agree that the m's can cancel? We cool with that? And you all cool that 6g cos x? Yeah? 6g cos x? And that's 49 minus 4g. See that 6g? I'm going to bring it underneath. And then in my calculator, I'm going to do 49 take away 9.8. Sorry, 4 times 9.8. And then I'm going to divide that answer by 6. Oh. Divided by 6. 6 times 9.8, thank you. We got 1/6. That sounds familiar to me. Cos inverse 1/6 for me. Cos inverse your answer. Oh, I'm in radians. Shift setup. Degree. Oh, mad error. That wasn't good. Cos inverse 1 divided by 6. We got 80.4. Is it 1 decimal or 2 decimals? Doesn't even say, does it? No. I'll go for 80.4. Okay.